Okay, so my name is Rich Graham, and what I'm going to talk about is MPI-3, what it is, what its status is, and how things are looking moving forward beyond MPI-3. So you probably know that MPI-3 became a standard almost 2 years ago now. 2 years? No, a year ago now. Forgetting time. And so there were quite a few organizations that participated in defining the standard. I have a list here of everyone that was all the organizations that were active. In itself, not so interesting, just to show that there was a broad participation across a large number of computer companies, national laboratories, universities, and the like. So, in that process, I happen to be the chairman of the MPI Standards Committee, and I'm still active on the steering committee for the forum. So briefly, I'll mention what the goals of the MPI-3 standard were. Talk about some major additions that happened in the standard. What things that didn't make it into the MPI-3 standard, those often are of interest to people. What was removed from the standard, because there were some things that were removed, what was deprecated, and something about current status of implementation. Actually, the slide is very, very recent. Been updated just within the last week or so. And then give a very brief overview of what the forum is doing now. So just for your information, the forum's actually meeting in Madrid right now, today and tomorrow, to continue its work. So really the intent of MPI-3, which we worked on for about 3 years, was to make big changes to MPI. It really addressed for the first time since 1997 big additions to the standard to add things that are missing. The intent up front was stated that there could be some big changes in terms of backward compatibility. While we tried to maintain backward compatibility, that wasn't a major objective. Although from a practical point of view, there weren't very many big changes that were at the end that were made. I'll go through a list now, really of the highlights. There are a tremendous number of changes that were made to the standard, both in terms of clarifying things, in terms of making small changes. There's no way that in half an hour I could even get close to talking about those, and you'd be asleep by the time I finish the list probably. So I'll really try and hit just the major issues. So the first item that was actually voted into the standard about 4 years ago. Actually, it was voted into the standard before MPI 2.2 became standard, but because it was a big change, was never included in MPI 2, was the addition of non-blocking collectives. So the notion behind non-blocking collectives, by its name, implies that you can start a collective operation and go off, and at some later time check and see if it's finished. So you have the intent there is to provide the ability to overlap communication and computation. There's really no limit from the standards perspective on how many outstanding collectives you can have at a given time. And a very important semantic that was maintained is the semantic of ordering, of the order at which collective communications are posted. So the expectation is that on all processes within a communicator, non-blocking collective communications will be posted in the same order. And it's done instead of trying to use some sort of tag to try and match up collective operations. That was a conscious decision that was made, and really intended at making it making it possible to have very, very efficient hardware implementations of non-blocking collectives, so that applications could actually, in practice, achieve overlap of computation and communication. The next thing, the next item on the list is neighborhood collectives, and really the intent here with neighborhood collectives is to provide for the very data-intensive collective operations, the various variants of all gather and all-to-all, the ability to describe sparse communication patterns. So that if you in practice you have a sparse communication pattern and can describe it by some sort of graph, there's a chance that you'll actually be able to use these sort of operations at very large scale, and that's really basically the intent of this set of routines. So this is one of the things that was done within MPI 3 to try and make MPI more scalable as we move towards exascale. There's a new tools interface that was added in MPI 3.0. The old interface, the PMPI interface, was retained, not deprecated at all, or removed, and a new interface that's really aimed at allowing both control and query of internals of the MPI library was added. This is not the first attempt at something like this, but this is the first attempt that made it into the standard. So really the intent here is to allow users to control in a standard way, control the way a communication library behaves, even though the internal, there's nothing in common between, there's very little in common between separate implementations of MPI. And also the ability to look at parameters that influence the performance of specific MPI implementations. So for those of you that are familiar with, for example, what an eager limit might be, or those of you that you have a notion that maybe how full a queue is somehow has some impact on the performance of an MPI. This lets you get at that sort of information and try and understand what the MPI implementation is doing this, and doing this in a standard, doing the query in a standard way. Again, to emphasize this, it does not by any means mean that MPI implementations are implemented in the same way. They aren't, but there's a common way now to look at these sort of parameters. And so really, there are two types of parameters, as I mentioned, that are of interest here. And I guess I'm showing the slide late. Those that control performance and those that control behavior of the library. Two-phase approach is used, and I will just show it here in the next slide. So there's first the ability to go in a standard way and ask the communication library what it supports, and once you get back some sort of response in a standard format, so that an application can understand what this means, then one can go and do something with those parameters. So each of these have a two-phase type of behavior first setup. After you've asked, then you do something with what you've asked, and once you got the response back, then you can start using it. So once you get the response of these are the parameters that are available, and you get handles for them, then you can register to actually follow those counters. You can start them. You can let them go for a while, stop the counters, read them, continue going, and the like. So to be able to make this work, and be able to profile, for example, what happens at MPI init or MPI finalize. These are a few of the MPI routines that are permitted to be manipulated, to be used before MPI is initialized, and after MPI is finalized, as it's the only way to be able to actually measure those routines. There's another capability that's been added, that of non-collective communicator creation. So for those of you that use MPI, which I assume are probably most everyone in the room here, you probably know that to create a new communicator, you have to use a collective operation. And so if you have a very large system and you want to create a new communicator with a small number of them, there really should be no reason for you to have to call create from all million processes that you're using if you want to create a communicator of size 5, let's say. And so there's the MPI-3 has added that ability, and in this case, only those processes that are participating in the new communicator are the ones that have to call the routine. So one of the goals from that, and I see on this version of the slide it's not very good. One of the things that it allows you to do is if you still today, even in MPI 3.0, you'll see later, there's not a standard definition of what happens of exactly what happens after failure. So different libraries may do different things. So if a library is capable of surviving failure, if an implementation is capable of surviving process failure, this lets you define a new set of communicators, a new communicator, without having to have that failed process participate in communicator creation. That means you can continue and use collective operations over that new communicator. So it's a form of allowing for some fault tolerance within the standard, within implementations of the standard. One additional reason to do this, and which was one of the goals of MPI-3, is also to enable support for what other communications called global array standards, communication specs or whatever, do today. So this was added specifically to provide capabilities that global arrays provides. So RMA was a remote memory access was a working group that was active for the whole time. As a matter of fact, in MPI-4, whatever the current version of MPI, the next version of MPI will be called the current activities. They're also a very active group actually trying to understand all the implications of some of what was put into 3.0, because it's clear that not all the implications were understood. So they're in terms of extensions to RMA. First of all, there are new capabilities. So the focus is really trying to make RMA make it possible to have implementations of RMA that optimize the capabilities that current hardware provides. The old model, there are arguments as to whether the old model enabled that or not. Most people believe not. Those that were involved in defining the spec in the first place believe yes. So there's quite a bit of split there. But the intent was really to allow native performance to be obtained out of using the MPI standard, and while maintaining backward compatibility to MPI 2.2, which did put constraints on the implementation. So the major new extensions that were added were new ways to create MPI windows, new operations to support read modify write operations, new request-based operations, so that you can complete RMA operations one at a time rather than having to use a synchronization mechanism to complete everything that has been issued up to that point. A new memory model that's really aimed at cache coherent systems, at the way most systems, not all systems, but most systems are built today, and other extensions to simplify use. So I have the list of routines here. If you're really interested in the list of routines, you can go and download the standard and look in detail. But there are a few interesting things. So you can attach memory dynamically to a created window. That is, when you create a window, you don't have to associate memory with it initially. You can allocate windows that are accessible via shared memory to processes that have access to a common shared region. There are some, as I mentioned, read, modify, write operations have been added. So the ability to accumulate data in an atomic way, fetch and op type of operations, and fetch and swap have been added. As I mentioned before, request-based operations. So these are exactly like the two-sided point-to-point operations, where you send one and you complete one. There's no way to complete things in batches. For two-sided communications, so same thing here. That ability has been added for one-sided operations. New synchronization operations, and as I mentioned, a new memory model, the unified memory model, that really is aimed at cache coherent at cache coherent systems. Like another thing, I don't know how many Fortran users are in the room here, but there are new Fortran bindings that were added, and really the intent behind the new Fortran standard is to one, allow for type checking to be supported, as well as keep up with the language, with the Fortran language standard as it evolves. So there's a new way that's called MPI-F08 that's used, that's defined, and really that version is consistent with Fortran 208 and the Tech Report 29113 and later. So if your compiler doesn't support those sort of versions of Fortran, then you won't have you won't have the support necessary for your MPI library. Will not be able to provide the support necessary for the new Fortran bindings. I'll talk a little later what the intent, part of the intent there was, and part of what was done in the process is make it possible to gradually migrate to the new interface. So you don't have to change all your code at once, but just the pieces that you want to. And so you could intermix this with the previous two ways of doing it, even on a per compilation unit. So you could have, in a single compilation unit, you could have all three methods being used by the application. So you can see here's additions to give the compiler hints about the behavior, about what's happening with the buffers, with the arguments, so the compiler can do optimizations if it so chooses to. Skip through these, won't go into a lot of detail. Also, many Fortran applications. I'm not a Fortran user, so I trust this is correct. We'll omit the last argument. That's the error argument in their calling routines. This is now MPI has formalized this as optional, so it's actually correct, and you shouldn't get any errors if that happens at times. The addition of keywords to the arguments, so you can just like in other parts of Fortran, apparently you can use keywords to indicate what the arguments are. And probably from my perspective, I think the most significant thing that this new standard did is tackle some problems that have existed with the way Fortran and MPI interoperate since MPI was defined in the first place. That is, those of you that are familiar, that use Fortran and have tried to use slices of arrays, know that there's the compiler can do things that you don't expect with the data. That can create temporaries that vanish without you knowing about it, and so it had to do tricks in the application to prevent the compiler from doing these sort of optimizations. And so basically, it made it very difficult to use from Fortran to use asynchronous communication calls under certain circumstances. Of course, not all the time. So what in this case, actually, both the Fortran Standards Committee as well as the MPI-Forum worked together to define what's required on both sides to solve that problem. And so, if your compiler supports Fortran 2003 and TR 113, this should no longer is not supposed to be a problem anymore. I will say that some issues came up after the standard was put together and ratified. One compiler vendor ran into some issues and realized that part of what was defined, if I remember correctly, it was the way Fortran interacts with. I think it's issues. Well, of course, it's issues with the Fortran compiler, but I can't remember the details right now. I think it had to do with some of the tool interface stuff. Those issues are actually being worked through now. The new standard is actually broken there. But in any case, this is much better than what was there before. And there is one reference implementation. Really, the only reason there's one reference implementation now is because, or the main reason is because it did run into these problems after MPI 3.0. So data types, in a nutshell here, in terms of data types, what was really done is an attempt. The main thing that was done here, aside from bringing up MPI to a state where it supports Fortran, C, and C++, all the standard defined data types in those three languages. It also took a first stab at trying to address the fact that all count variables, or most count variables, in MPI 2.2 were defined as integers. So anytime you wanted to go for a number beyond 2 to the 32, you couldn't. You could, but it was unpleasant. So there's a new data types that were introduced. MPI ANT, MPI count, and MPI offset. That are intended to deal with these. And all the new versions of the routines that look at data type and query data types have been added to support these sort of these data types. Nothing has been done in terms of the actual routines that manipulate data. So MPI send, all gather, all those sort of things, those were not touched. There were many discussions on what to do there. Because no one wanted to double the size of the number of routines and have everyone have to call MPI send X or something like that. So I know the forum will come back to this at some point. I have no idea what will happen there. So that's the issue of large counts that I just talked about now. Match probe. Before MPI 3.0, and actually even in MPI 3.0. If you probed, if you did a probe for a data, for some sort of arriving message, some sort of receive, you could have another thread doing the same probe, and so even though you found a message, by the time you posted a receive for it, another thread could have grabbed it, and so you won't be able to complete. So there's a new routine, there was a new support for a matching probe that was added, that basically once you probe the data, you get a handle back, and the only way to read that data now is with that handle. And so if someone else probes, that message is treated as matched, and so you don't have a race condition where two threads may get the same, or multiple threads may get the same information on the same message, and both try and match it, and one succeed and one not, or more than one succeed and the rest not. Topology aware communicator creation. So here is the ability define a parameter that's of meaning to your system. It's the only meaning that's defined within and split communicators based on that trait. So the system that was defined is an extensible system. The only parameter that's defined in the standard right now is for shared memory. So you can say, give me all, split this communicator based on who shares memory with me. That's defined in the standard. The individual implementations are free to add additional parameters, like give me everyone that shares the switch, give it whatever that means. Give me everything that's on the same rack, whatever is relevant to the implementation, and actually to a topology for that matter. Removed functionality. So for the first time in a long time, there was functionality removed from the standard. Removed means is different from deprecated. Remove really means it's no longer part of the standard. So remove means that those that support MPI 3 don't have to have that functionality in their library anymore, which is very different from deprecated. Deprecated is an intent to remove, and notification to the users that there's an intent to remove at some point. Deprecated means it's gone. So in MPI 2.2, support for C++, native support for C++ was deprecated. In MPI 3.0, it was removed. Now I say that not in a light manner, because removing functionality is something that anyone that has to support customers does in a very, very cautious way. The reason this was done was because the bindings as they were in the standard apparently were very non-intuitive to C++ users. And most C++ users actually use the C interface. We actually did spend quite a bit of time. Vendors went out and checked with their users and stuff like this before we made that decision. It came back that it was an easy decision. After they were removed, of course, we found out that nothing's an easy decision, but they're removed from the standard. There was actually one instance that people were very unhappy about it, but it's no longer in the standard. There are a few minor things that were deprecated almost 15 years ago that have been removed. The things around data type handling. Deprecated functionality. You notice nothing was deprecated. Probably more interesting is what something that's very interesting is what didn't make it into the standard. So there was stuff that was worked on for a long time. The forum had been meeting for 5 years by the time MPI 3.0 came out, and throughout the whole time, the fault tolerance working group was active, and for a long time, the group that was working on hybrid programming issues, that is MPI plus something else, which something else usually meant some sort of threaded model, nothing made it there. Those didn't make it. Immediate versions of the non-blocking file I/O operations, they also didn't make it. So there was an intent to sort of make it similar to the non-blocking data exchange operations, and those didn't make it up. And there was another issue around clarifying what it means to have multiple MPI processes within the same address space. That also didn't make it into the standard. And of course, there are a lot of other things that were worked on and didn't make it in. But these were really big ticket items that didn't make it in. Well, first, before I go to and talk about what some of the things that are happening right now, this is a list of MPI implementations and their status with respect to the MPI 3.0 standard, supporting the MPI 3.0 standard. I didn't list here, so some MPI vendors didn't respond at all because they just don't respond about things that they don't have as products. And so so they're not on the list because of that. Intel MPI is one that comes to mind. So the intent there is not to say anything about it because they just don't They just don't comment about those sort of things. So those that are based on MPitch have a lot of the functionality implemented. IBM, so this must be their version that's I can't remember if this is the version that used to be, I can't remember which, IBM has 2 MPIs, and I don't remember what version of MPI that is, but they expect to have full support the spring of this coming year. OpenMPI, basically the decision there is to support when there's demand. So there are things in the standard that people really don't expect users to use, and so there's no intent to implement those. You can see Fujitsu follows OpenMPI. I'm not quite sure what their release dates are, or how far along they are there. SGI MPT, I believe they're MPitch based, and you can see their schedules there. Having said that, this is just what's supported. That doesn't necessarily mean that things are optimized or anything like that. Notice that the support for Fortran 08 bindings is deferred because of the issue that came up, that was discovered during one of the implementation, one attempt to implement this, and the like. In terms of what's happening now, I will say that everyone in the room here can have influence on what happens now. Those of you that want to participate in the forum, it's open to organizations. You're very welcome to participate and influence what happens. The meetings have been scaled back to only 4 times a year, 3 days. And as I said, the meeting is actually going on right now in Madrid. Ends tomorrow. The current meeting. So if you want to influence things that are on the list, get involved. So fault tolerance is continuing to be worked. Fault tolerance was close to, actually, I said it didn't make it into MPI 3.0, which was true, but it was close to making it in. There was too much change in terms of what was being proposed that people wanted to give it a little more time to ripen on the vine before doing something with it. So we fully expect, there's no longer the controversy that existed 2 and 3 years ago, or not to mention about 5 years ago when the whole process started. It's sort of a given that the fault tolerance will be supported in the next version of MPI. Depending on what next means, that isn't quite decided yet. Again, there's more work on what MPI should do to fit better within the broader context of programming models. It's not quite clear what will happen there, because in reality it really takes cooperation between more than one standards body, and the only place that's worked well so far has been with Fortran. MPI, there are cleanup. So a lot of what was added to MPI 3 had prototypes before they were standardized, but a prototype, of course, doesn't address everything. And so as people are getting full-blown implementations of the standard, starting to realizing some things, some small, and as I said, some not so small at all, that were just missed, not because of lack of due diligence, just because the standard is big, and when you try to optimize things, you do things different than when you're trying to prototype. I should have added here is support for the split operations for the asynchronous operations for file I/O. Those will make it in. It was really a technicality that caused quite a bit of consternation on behalf of several people that they didn't make it into MPI 3.0. So those are fully expected to be in the next the next version of MPI, whatever that means. And of course, people are there's the tools working group is active. And those are really the ones. This is mostly what's going on now in terms of the standard. That's all I had.